Once again, good morning, and going quickly back to what we have done so far. I know we had a couple of sessions. We talked about database, evolution of database, how the storage has evolved, what is DBMS. I think that's pretty much where we stopped, and we went through the data processing cycle, right? How the data gets fed in, how it gets processed, etc., etc. Let's slowly keep moving. Today, I want to introduce some of the terminologies that we use in DBMS, all right? If I could start sharing my screen, then I can pull up some of the terminologies that is used in DBMS. All right. Somebody confirm that you're able to see my screen on your chat if possible. Yes, thank you. Okay, so some of the terms that I'm going to introduce today are these. Okay. Okay. So this is a small table that we have, kind of looked at it in our previous sessions. I kind of showed you how the data was in files and how it went into tables. This is a small table. This is the table that we will develop in DBMS and then use it. Okay. How do you develop this how do you develop this table? We'll talk about it as we go down. But assume we have created this table. I want you to closely pay attention to some of the terms that I'm going to use. This is the name of the table. What you see here, student table. Every file is given a name. Same way every table is given a name. So a table is given a name. This is called a student table or student information table. That gets a name called entity. A table is called an entity. In DBMS terms, a table is also called an entity. Okay. And all these columns that you see represent an attribute. I'm going to introduce the term attribute or fields or a field. Okay, every column will have a header. Okay, for example, the first column is student number, second column is a student name, gender, date of birth, average grade. Each column has a header, and each of them is called an attribute of the entity, or it's also called the field of the table. Okay, and moving on, each line, or if you want to use the term row, is called a record. Okay, what does each record represent? It represents a single instance of the entity, correct? The entity is nothing but the student table. What you're seeing, the first line, student number, birth, gender, male, grade, and average marks, is representing one occurrence or one instance of a student table or of a student, or it's a details about a student. So what I can say, a record is nothing but one instance of an entity. Okay. The other name for record is also called tuple. Some people call it tuple, but I prefer saying tuple. Okay. And I want to introduce another term called domain. What is a domain? Domain is nothing but the range of values a column can take. For example, for name, I cannot define a range. I cannot just say only these names can be entered in the table. No. But whereas when it comes to gender, I can say, can either take a value male or female, right? So I'm defining a domain to it, a range of values to it. So that's what is called a domain. Same with the grades. I cannot enter a grade from A to Z. There's only a grade like probably 4 or 5, A plus, A, B, C, whatever. Okay, so these are some of the basic terminologies. Again, there may be questions in your exams. Explain the various terms of database, or there may be specific questions of what is an entity, what is a record, what's an attribute, okay? So quickly, if you want to define, and I leave it to you to go through the textbook for definition, but if you want to define your own, words, if you understand what I said, you should be able to write. An entity is nothing but a table, okay, a name of a table, or you can just say it's usually a table that represents a noun, basically, okay. An attribute is nothing but a column of the table, filled the same ways. Record each instance of an entity. Domain is a range of values that a particular column can take, okay. With that, I'll keep moving. What I'm going to request you guys is, after I'm done, I don't know, you may be doing it already. After I'm done, I want you to go back and go through your textbook, read through it. If what I speak doesn't make sense with what is on the textbook, bring it up. We can go through it together, okay? I don't really go through your textbook word by word, but I do go through it to take some content out so I can explain to you guys. But if you think, ultimately, after I'm gone, your textbook is your best companion before you go to the exams. So if you think anything that is given in the textbook doesn't make sense with what I explained, feel free to bring it up to me, okay? Now, we're gonna go back to talk about a little bit about DBMS data types. This is like another question about what are the different data types used in DBMS, okay? You might want to elaborate some of it. It's usually a 2 or 3 mark question. So some of the data types, by now you should be knowing what all kind of data can go in is basically numbers can go in. For example, your marks. Your marks can be numeric, right? So numeric data can go into your tables. When I mean by numeric, what are the different types of numeric data? Could be integer, whole numbers. Then you have float. Float is basically, we don't use the term float here in DBMS. Instead we use small int or big int, small or long precision. It's not very much used, but I would like you to know that. So float is basically where you want to use decimal numbers, okay? And currencies, in the banking scenarios, people define that this column can take only currency field, for example, bank balance or your account balance. So that's currency field. So you can define a data type to be currency. So any number you enter into it will be treated as dollar amounts or currency amounts. And then index, what's an index? Index, I think I spoke a little bit about index. Index is more like this. If I could use an example of a library, you go to a library, they store details about a book, okay? They take a book, for example, an encyclopedia, they store the name of the book, additional details about the book. For example, who's the author, how many pages, who has borrowed it, when is it due for return, etc. And apart from that, they also store and metadata. I introduced the term in the very first class, something called a metadata, data about a data. So there's a separate table that they maintain to say, where is this book located in the library? They're not going to store anything about the book. The details about the book is stored in a separate table. Now they are storing data about the actual data, meaning where is this book located? So they put the book name, or maybe they call ISBN number, whatever. Put the number and then say this is located in this particular location in the library. So that's a separate table. And with that location, you go to the actual table and then read details about it, whatever you want, if you want. Looks like I have a chat. Where is this? Yes, so just want to use the term metadata, okay? So what I mean by index here is basically you're storing a reference or something that using which I can quickly point to the actual data. I don't know if the concept of OOPS is covered. I know you guys study that as part of your curriculum, object-oriented programming. You'll talk about pointers there. So pointers are nothing but they point to an address. The actual data sits somewhere else, but you have a pointer, the address store, right? So that's basically kind of an index. We'll use this terminology a lot in DBMS. What is an index? How is an index managed? What's a primary index? What's a secondary index? Things like that. Okay. So basically, in numeric data type, these are some of the data types, sub-data types. You have integer, float, or long and small precision data types, currency, and index. Okay. Now, other than numeric, you can also store character data. Now, what I mean by characters is alphabets. When you store character, you can just store a single character, like your grades, just A, B, C, or gender, like male, female. Or you can also store a string, like a set of characters. For example, your address or your name, okay? So those are used to store a set of characters. There we go for text. We define a text field which can store a larger character. They're pretty much the same. The difference is that the character can store only a limited set of characters. I'm assuming in RDBMS they are limited to like 8,000 characters, whereas in text you can go beyond it. I think there is it's customized. I think it's about 2 GB of data even in one column. We don't use store that much, but usually a text field allows you to enter a larger statement or a sentence, whereas character is usually like one word, mostly one word or 2 words, okay? You see the other term called Varchar, it stands for variable character. Varchar, if you break it, it stands for variable character. What it means is this: I'm defining character data type for a column. When I define the character data type, give me a quick second, I'm gonna stop. All right. So variable character, what a variable character means is if I define a column for an address, some people might have an address which is only 50 characters, some might have an address which is 500 characters. So by defining a fixed length for that column, what I'm doing is I'm wasting memory. If I define 500 characters of length for an address, and if everybody stores only, let's say, 50 characters length of address, I'm unnecessarily wasting 450 characters of space for each column. Because the moment I define the data type as character, system will internally reserve 500 characters for the column. Whether you use it, you don't use it, I will give it to you, which is a waste of space. So for that, variable characters comes into play. What I mean by is after somebody puts the data in, evaluate the length of the data and use only that much of storage. Okay, that's variable character. And text like expand is more like strings. And date and time is again another data type. You can define a column to be just date, where you store only the date, mostly in the form of year. Usually in DBMS, all DBMS stores the year first, then the month and the day. Okay, so it's YYMMDD. Or some of the columns you can define as only time, it stores only time. You can define date and time, so it can store both data and time. Or you can define a data type for a column to be only year, stores only the year. Timestamp, a lot of places timestamp is used. I mean, this is very critical because in practical scenarios, like in the projects that I worked, most of the times we capture timestamp. Usually it's 26 characters long. Why do I store timestamp? Because there are millions of transactions that happen every second. Like for example, I have worked in healthcare, health insurance. I've worked in different domain logistics like transportation, etc. There are a million transactions that happen in a minute, right? So if I just capture data based on date and time, there will be at least 10,000 transactions in 1 minute. So for it to be more specific, we go into milliseconds and microseconds. So we store the timestamp, last timestamp, and then based on that, we differentiate the rows. If you want to see who last modified, we always take the timestamp. And from the timestamp, you can get your date, time, whatever you want. Make sense? And one other data type I want to talk about is logical data type. It's more like Boolean, yes or no, true or false. If you want to store, for example, the telecom industry we're talking about. So there is a feature for students, if you're a student, there may be a promotional offer for you. So the telecom industry might want to understand, is this customer a student or no? So that particular column, student yes or no, can take only values between yes or no. It's a Boolean value, true or false. Nothing other than that. So that's logical database. Logical data type, okay? Make sense? If there are questions, feel free to unmute yourself and then talk. Otherwise, I'm going to keep going. Remember our base ground rule. If it's boring, you got to stop. You know, otherwise, I'm going to continue. I'm just trying to pull out your textbook. A little bit about some of the terms. I don't want to really spend too much time. This is for your awareness. Like I keep saying, I am not teaching only for concepts. I'm not teaching only for exams. I'm basically not teaching. I'm only talking. Okay, let's use that term. Teaching, the moment I use the term teaching, everybody gets bored. Okay, nobody wants to listen to a teaching. Like I said, it's the power of teaching. You get to sleep easily. So I don't want to use the term teaching. Instead, I'm talking or coaching. Okay, if you want to use the term. I'm bringing awareness to you, okay? So this is not something I really want to get into, but just for, like I said, awareness, different types of DBMS that exist. You know, who depending on which company created it, there are different DBMS that exist in today's world, okay? All right. Microsoft as SQL Server, Oracle as a DBMS, Oracle is the name of the organization, the vendor, creates Oracle database, or created IBM as DB2, which is very powerful. I work on DB2. I've been working on DB2 almost 20 years now, close to 20 years. I've been working on DB2, different features of DB2. It's very, very powerful, believe me. IBM also has a very major technology called mainframe. I can talk for hours together. That's my other area of interest. IBM has the mainframe technology. When it created its technology, it has its own front end, its own back end, its own database, its own file system, its own operating system. So IBM has its own different modules of technology. For mainframe, DB2 is one of it. It's for the database. It doesn't use anybody else's database. It is very powerful. It's very sharp. Okay. If you happen to go into mainframe technology, you guys will learn more. Oracle also has MySQL, and SAP creates Sybase. From my experience, pretty much Oracle and DB2 are into usage a lot, okay? The features remain the same, you know. At the end of the day, when you want to talk to DBMS, you have to talk through an SQL. You cannot just go talk your language, it doesn't understand. So you gotta talk through an SQL, structured query language. That syntax remains the same irrespective if you use DB2 or SQL, DB2 or Oracle or Sybase. A very minor syntax variance. Okay, all good so far? All right, this is again another important from your understanding perspective as well as exam point of view. There may be questions. I think you have 5 more questions, I believe, if I'm not wrong. There are questions about, can you explain the features of DBMS? What is a feature basically means why. If I can convert the question to why do we use DBMS? That's what we're going to answer here. Okay, so 5W1H rule we have been talking about, right? So we talked about what is DBMS. We explained the definition of DBMS. Now I'm going into, we also talked about where is it used, basically the applications of DBMS. Now I'm going to why is DBMS used? Why am I not happy with what I already have? You know, that's always a basic question, especially in the industry, today's world. When you take a new proposal to somebody, people are afraid to accept and approve it because in current world, everything revolves around money, right? Anything that you want to do involves funding. Without money, nothing happens, right? For example, I go to my client and say, okay, can we implement this? This will improve your efficiency, your speed, your performance, the number of transactions that happens in a minute. The client will appreciate the effort. But the next question comes out as, what is the cost to do this? Then I say, okay, I'll probably like a 10 million. Then they're like, oh, no, we are not interested. You know, it's not, we don't have money for it. Or why should I invest my money in something that is already working, right? This is already working. Why do I want to invest money? More like that. So there is always an advantage to something. Always it comes with a disadvantage. So it's always evaluated between advantage versus disadvantage, right? Pros and cons. So now we're going to feature of why not a file system? Why not continue using the file system? Why should I use DBMS? Okay, what is it going to help me with? Now, I want you to wake up and pay very close attention. These are very important terminologies. If you have been sleeping so far, that's okay, but wake up now. These are very important terminologies. I don't want any of you to memorize this. Instead, go into your, what do I say, into your blood if I use the term. And if you understand these concepts, there is no need for you to go through a textbook, right? If you understand it, you talk to anybody, you should be able to bring the whole concept and talk about it, okay? With that, let me get in a little bit. Number one is reduce redundancy. Of course, reduce data redundancy, we have been talking about it. Everything here is about data, okay? Database, everything, all the D's are for data, okay? So reduce data redundancy. How do you reduce data redundancy? For me to explain that, let me go back a little bit and pull up the files that we have used earlier. Can you quickly explain to me, somebody can unmute or put it in chat, what are the 3 different files that we used to represent our data before we came into this format of storing data? We kind of put the data, brought the data into this table format, or basically, if I can go all the way up. So we put all our data into this table. If you guys can, where's my screen sharing? Okay. So this is the table that I used in the very first class, where I have student name, marks, and the grade. So before I started using this table, I want at least some of you to ping me and tell me what are the different files that I used. I had all this information in files. And if you guys remember, what are the files that I've used? If anybody wants to take a guess, if you still remember, what are the different files that I used? Not the terminologies, but in the very first class, I used some files to store this information. Not in one file, I stored the information on 3 different files. It's okay if you don't remember, but I would appreciate if you remember that. I used 3 different files in my very first class. All right, so let me do that screen share. So these are some of the files. So this is one file that I used, okay? This is basically the student file. So I used one file here to store just the basic student information, okay? And I used a separate file. A marks file here. So this is the other file that I used, okay? So the first file, student file, had your address, date of birth, gender, everything. That's basically a general information about students. And I use this file where I put in all your marks here, okay? And then I use a third file to store your grades. So this is my grade file, right? I used your student number, student name, and your grades, whatever it is. So quickly, I have a question here. Between all these 3 files, what is the common information that I've stored? I opened up 3 files. If somebody is coming to me asking somebody's name, date of birth, and then their actual marks, and then their average, I need to go through all these 3 files. The first file to find your name, and then your address, date of birth, everything, and the second file to go through your marks, and the third file to get your grade. Now my question is, what is the common information that I have in all these 3 files? Anybody? Student number and name. Thanks, Molya. So yes. So what I'm doing here is in all 3 files, I was repeating the student number and student name, right? That is what I'm trying to mean by redundancy. Redundancy means duplicating. Having something that is repeated, that's unnecessary to store, okay? So that is what I mean by redundancy. So here, if you go into my other file, other table that I used here, I'm still sharing. So here I have the student number and name just stored only once, okay? And then I have the rest of the information put together. So by going into DBMS, what we are doing is we are reducing redundancy, okay? So I'm not storing the student number and name multiple times. So this is what is redundancy, okay? Now, what's the next item? All right, so I'm assuming that's clear. The next item is enforcing data integrity. So this is again another important terminology. How do you enforce data integrity? What is data integrity? Data integrity basically means all the data is stored intact. Intact meaning for example, if I want to go to my third file and store somebody's grade, I can just open the third file and put, for example, I got a new student joining today, or a new student comes and reports his marks. I can go directly to the third file and then directly put the student's name. For example, I open the third file, start entering data saying, okay, name of the student is Priya, let's say the grade is CA+. I can do that in my third file. But technically speaking, you cannot have somebody's grade without having their basic information and their average marks, right? You cannot compute or store an average mark without storing their information in the other two files. So that's basically what I mean by data integrity. Whereas if you go into tables, your table will not allow you to store that information. We can put constraints on the table saying, do not allow somebody to enter a grade unless until all the other information is stored, meaning their name, their student number, their address, date of birth. Unless all the data is entered, do not allow somebody to put their marks or grade into it. Make sense? That's integrity. Basically, it maintains all the data intact. You cannot just break some data and put something and leave something blank. That's not possible. All right? Questions? Feel free to stop me. Okay? All right, moving on. Data sharing. This is another very good example. Data sharing basically means you put the data, centralized database. We use the term centralized database. What it means is, again, going back to the same banking example, about 20 years back, assume you go into a bank, you got an account in your bank. Assume the bank had branches both in Bangalore and Mysore. If your account is opened in Mysore, you deposit your money in Mysore, you go into Bangalore and then you need money, it was not possible for you to withdraw money from your Bangalore branch because your base branch is in Mysore. You deposited your money in Mysore, so it will not allow you to access your information. If you go to the same bank in Bangalore and say, okay, I need my money, they will not have any clue about your account. If your branch is in Mysore, only the Mysore branch has all your details. But whereas with the DBMS coming into play, we take the DBMS data, we put the table into the central network, I should use that term. You'll study about networking a little later, or maybe you might have done. You put the data on the central database or on the central network, and across the globe, you can access the data. For example, that's what happens with today's ATMs or online banking. You go anywhere in the world, still you can withdraw money from your account. You can check your bank balance. That's because anything that you use, any medium you're using to talk to your account, because the account is placed on a central network. Make sense? So that's what is meant by data sharing. Data sharing becomes very easy in terms of a DBMS. And then data security is again another feature. It's easy because DBMS by itself comes with a lot of security features. If I create a data in a file, anybody can open and check. If everything is logged in paper form, anybody can get access. Anybody can damage it. A lot of times I've heard in a lot of organizations, especially public organizations, public sector saying, oh, there was a fire, the ledgers are burnt, we don't have data for it. And it happened in one of the organizations. They said, people who are born before this year, we don't have your birth certificates because all those ledgers were burnt, all right? So you don't have security there. But whereas with the DBMS, you don't have that. I mean, there is always problems with electronic forms of data, but it's very limited. It's not like the ledger is lost, it's torn, or my kid burned it, my kid torn it, and you don't have that feature. Okay, moving on. Then ease of application development. This is again another important feature. Ease of application development. You have, when you create a DBMS, the end user cannot directly talk to it. For example, we'll talk more about it as we go down, but quickly. If I create a database for a banking application, the database is nothing but storing, if I could use the definition of it, stores related data. Okay, it stores data. For example, I take, for example, Rohan. It stores all the related details about Rohan, all the related data. That's what relational DBMS is about. But who can access the data currently? Assume the data resides in the database. Who can access it? The end user cannot read the data. For example, you create a DBMS because you become a DBA, you create a table, you put the data, and tomorrow if Murli wants some data, assume he doesn't have exposure to DBMS, assuming, okay? He cannot go to the DBMS and get the data. So he has to depend on somebody to fetch the data. So what happens is the application comes in between. You create an application, and then like the mobile phones we use, go through this mobile phone, click this button, you can get the data. So what's happening is you're creating an application. The application talks to the database. How does it talk? You create some connectivity. There is something called DBC, database connectivity. The application, whether it is C, C++, Java, HTML, whatever you use, talks to your database, fetches the data, puts it on the front end, right? That's application development. So the ease of doing application development is more in DBMS rather than using file system. In current world, people are trying to get away from file system because it's being very, very difficult to understand the data put in the file. And a lot of times, like I said, in my client place, I get a lot of data about 40,000 characters long. It has all the data padded next to each other. Like for example, I have some information, if I could use an example, student number, student name, etc., etc., etc. 40,000 characters of data next to each other. If you look at the raw data, you will not even understand what is this, okay? So it's very difficult. So people are trying to get away from the file system, okay? So moving on, that makes it more easier. Then access via multiple UI. So that's again another point I was talking about. So you can develop multiple types of applications. For example, what are the ways that you access your bank balance? If I could use that term, what are the ways that you access your bank? If you go to an ATM, you can use it. You can log in through your laptop or your desktop, whatever it is, you can use it. Through your iPads, through your mobile phones, through your app. Nowadays everything is on an app. You don't need to go into your laptop to log in. Use an app. So there are 3 different ways that you're accessing your bank account: ATM, your mobile app, your desktop application. So all of them are talking to the single database. It's not like you log in through you go to your ATM, it shows you different account balance. You log in through desktop, it shows you better bank balance. It shows you more than what you have. Or if you go through your mobile phone app, it shows you something even better. No, it doesn't do that, right? It's whatever mode of UI stands for user interface, it still accesses the same database, right? So it is possible with the DBMS. It's very easier to access via UI. And then next we're going to talk about a backup and recovery. This is very easy because if something breaks, like for example, I talked about the ledgers getting burnt or being torn, file system being corrupted. Whereas with the DBMS, it's very easy to back up and recover your data because DBMS by itself comes with that feature. You can back up. I can go to my DBAs and say, look, I need to go back to yesterday's data. Give me everything, because they usually maintain a backup. I can go tell them, give me my DBMS as it was yesterday. Ignore whatever I did today because there was some data corruption happened today.